So what prefix multipliers does for us is to allow us to express really large numbers in a convenient way and also very small numbers in a convenient way. And these multipliers change by the powers of 10, which makes it easier, right? So for example, 1 kilometer means uh, 1,000 meters, right? So 1 kilometer is 10 to the third meters, right? So 1,000 is the same thing as 10 to the third, right? So it makes it easy to express really large numbers or really small numbers. So just take a minute here to look at this slide, right? Where you see the red dots are the ones that I want you guys to know, right? So these are the prefixes. There are 9 of them total that you need to know. And what I want you guys to do is actually memorize the exponent that is associated with each prefix. You also need the symbol, okay? Right? So as you can see, giga is used to express a really large number, like 10 to the 9, which is a billion, okay? So giga means a billion something, okay? So 1 gigabyte, for example, is 1 billion byte, right? So another way to say that, 1 gigabyte is 10 to the 9 byte. Okay. So rather than writing 1 with 9 zeros behind it, isn't it easier to just write 10 to the 9? Right? It's the same thing, right? 1 with 9 zeros behind it is a billion, and so is 10 to the 9. Okay. And then mega, right? You know how I remember it? Mega millions, like the lottery. Okay, so mega is big M, and the multiplier is a million. So you multiply up by a million, right? So that's 10 to the 6. Okay. So huge numbers here, right, gets truncated to just, easily 10 to the 9 and 10 to the 6. So that's how I remember is I'm going to associate giga with 9 and mega with 6. Okay. So I can associate the prefix with the exponent, and I feel like that's one of the best tricks, to learn this. Okay. And then we keep going down, right? Kilo, the multiplier is 1,000, so that's 10 to the third. So notice already there's a pattern here, right? From giga to mega to kilo, it's going down by 1,000, right? 9 to 6 to 3, okay? So you're gonna associate that with that, okay? And then we get, if we drop down 3 more, that's 10 to the 0. And remember, anything to the 0 is 1. So that's it, that's our baseline, right? Now below that would be a number that's smaller than 1. So deci is smaller than 1.1, right? And a number that's smaller than 1, then it's going to get a negative exponent. Does that make sense, right? And so now we start to have prefixes that express small numbers, okay? So deci then is 0.1 or 10 to the negative 1. Centi is 10 to the negative 2. So again, that's what I do, right? I'm going to associate these exponents with the prefix. And as soon as you start have that memorized, right, everything else comes easier, okay? And by the way, this will be on the first quiz. It's always a section that really kills people. I don't want to scare you guys by saying that. I just want to impart to you, right, to study hard on this section, right? Ask lots of questions, come to office hours to really get this part. Because historically, it's just the one that is sort of the killer on the first quiz, right? But if you spend, if you practice it, you'll get it. Like it seems confusing at first, but give yourself a chance, all right? Come and ask me, and we can do problems together if we need to. All right, so let's keep going, right? Centi, 10 to the negative 2, milli, 10 to the negative 3, and then it goes by threes again, right? Negative 3, negative 6, negative 9. So negative 6, right, micro, nano, negative 9. Okay. So, and then, oh, one more. We got pico, right? You see that? 3, 6, 9, 12. So it's going by 3. So 10 to the minus 12 is pico. Okay. So once you have that memorized, now you can start writing what I call equivalencies. Equivalencies would be like, this is equal to that, right? So um, here's an equivalency. So I'm going to go away from the slide, go back to the board so you guys can see this nice and clear, right? What we're going to do is just write equivalencies. So have that have that slide still on your screen so that you are looking at it and you can reference it. Okay. And we're just going to start at the top, right? Just start at the top. And these prefixes can go with any unit, right? So for example, if I have 1 giga apple, I have a billion apples. Does that make sense, right? If I have 1 giga oranges, right, then I have a billion oranges, right? So notice it doesn't matter what I put behind it, right? Apples or oranges. Well, of course, we don't measure that in science, so it's better to do something like 1 gigameter, for example, right? So if I'm trying to measure distance, right? 1 gigameter, right? Big G is giga. Then what that means is I have a billion meters. Okay. So you see, this is why I call these equivalencies. And this is the first thing that you need to do is to learn to write these equivalencies. Right? Because the next step is when we do conversion. You can't do conversion if you don't have the equivalencies. Okay. So the first thing you do is write these equivalencies. The next is mega. Now, let's just change it up. Mega what? Let's not measure distance this time. Let's try, we're going to measure volume, right? So we can say liter. 1 big M, big L. Remember, big M is a million, mega millions, right? So 10 to the 6 liters. Okay, right? Isn't that equivalency? Okay. This is akin to doing something like $1 is equal to 100 cents. Right? That's an equivalency. It's a true statement, isn't it? So if I owe you $1, I can give you 100 cents. You wouldn't be mad at me, right? And vice versa, right? If I owe you 100 cents and I give you $1 bill, you'd be fine with it, right? That's what equivalency is. And it's just the same thing here, right? If I have 1 megaliter, then that is the same thing as a million liters. Okay. So I can keep going, right? So I can go to kilo, and let's measure mass this time, okay? So we're just practicing with different units, and you should do that too, just so you can get used to seeing it, right? So kilo, that's your prefix. 1 kilogram is 10 to the 30 grams. So notice all we're doing is we're translating, right? Giga is associated with 10 to the 9, right? Mega, 10 to the 6, kilo, 10 to the 30, okay? And then we can also keep going. We can do the small ones too, right? So let's say we want to do deci. 1 decimeter, going back to meters, right? 1 decimeter is 10 to the minus 1 meters. Okay. 1 milliliter is 10 to the minus 3 liters. Okay. Straight up writing these equivalencies, right? And then 1 microliter is 10 to the minus 6 liter. Let's change it up to gram. 1 picogram is 10 to the minus 9 grams. And then go back to meter. We have pico, and then we have what's after pico? Oh, sorry. Pico would be the last one. Nanogram is 10 to the minus 9. Pico, let's go back to meter. 1 picometer is 10 to the minus 12 meters. Okay, sorry about that. Little brain fart there. All right. Okay, so hopefully you're seeing that, right? We're just writing equivalencies. Okay, so very important that you get these. Okay, now the next thing I also want you to do is write it the other way around. Okay, just so that you see both. Okay, and that you don't that you're used to seeing both. So we're gonna do something like this. When I say $1 is equal to 100 cents, I can also go back and say 1 cent is $0.01. I guess. Okay. So I know at this point I feel like, yeah, my brain's hurting a little bit, but this makes absolute sense, right? Um, And we can rewrite 0.01 as 10 to the negative 2 dollars. Okay. Just to keep, the exponent form. Okay. So how do we do this? Well, it's just algebra, right? If you want to isolate cents here, you want to make this a 1, you divide everybody by 100, right? So you divide this by 100, that'd be 1 cent. Divide this by 100. 1/100th is 10 to the negative 2, or 0.01, right? Okay. So it's a matter of what question you're asking, right? Whether it's more sense to write this or this, right? So if I ask you how many cents are in a $1, then it's 100 cents. But now I'm asking you how many dollars are in 1 cent. It's the second question, right? How many dollars are in 1 cent? So 1 cent is this many dollars. Okay. Right? So the 1 is sort of like your reference point, right? Because I'm like asking for $1, how many cents is it? Now for 1 cent, how many dollars is it? Okay. Well, in all of these, the way we've been writing it is 1 gigameter is 10 to the 9 meters. Well, what if I want to ask in 1 meter, how many gigameters are there? Right? So in 1 meter, how many gigameters is there? Well, if I want to get this to become 1, I divide by 10 to the 9. So if I divide by 10 to the 9, it comes over here as 10 to the negative 9 gigameters. Okay. So 1 meter is equal to 10 to the minus 9 gigameter. I know that there's a little glare right there, but if you go and stare at the screen, you'll see it. Okay, but I'm going to read it to you, right? 1 meter is 10 to the 9 gigameter, right? So these are one and the same, right? It's the same thing. It's saying the same thing. It's just written in a different way, okay? But I do want you guys to get used to writing it in multiple ways, okay? Because you're more versatile that way, okay? Now, you can also do it to let's do it to, let's do it with the milliliter here. Okay, so I can ask now, 1 liter is equal to how many milliliters? Right? Well, 1 milliliter was 10 to the minus 3 liters, so 1 liter is going to be 1,000 milliliters, or 10 to the positive third. Because what I've done is I bring this over here and now change the exponent from a negative to a positive, right? That's when I go to the other side, right? Bring 10 to the negative 3 to the other side, it's going to be positive. Okay. Same thing here, right? 1 liter is 10 to the 6 microliter. Okay. And so I really want you guys to sit with that and see, you make sure that you understand that. Like, these are the same statement, right? Same statements, just written different ways. And, why is that useful? Well, later on when you're doing problems, you can use either this true statement or this true statement. It doesn't matter to solve the problem, but it gives you the flexibility, right? Okay. Another way to see this, okay, so that you don't actually have to memorize if it's negative or positive exponent, is to think in terms of bigger and smaller denomination. Okay, so let's go back to the money as an example. Okay, now the dollar is a larger denomination, right, than a cent. If you compare $1 and 1 cent, which one's worth more? The dollar. So of course, $1 will give you a positive exponent, 10 to the second cents, right? Because what you're imagining is tearing a dollar into 100 pieces. And each one of those pieces is called a cent, right? So since the dollar is bigger than a cent, you're going to have more cents in $1, right? More cents than $1. This is a 1 and this is 100, right? So that will always have the positive exponent when you're going from bigger to smaller, okay? You're going to have the positive, right? Exponent is going to be positive, okay? But in this case, you're going from cent to dollar, right? Because the question is asking 1 cent is how many dollar? Well, the cent is a smaller denomination, which means that, 1 cent is not going to be worth that many dollars, right? So it's going to have a negative exponent. but the exponent is the same. It's 2 for both, right? So that's kind of cool. You don't have to, um, the exponent stays the same, right? So you just have to worry about flipping the sign. So what that means is when you're going from smaller denomination to bigger denomination, right? You have negative exponent. Okay, make sense? Okay, so let's see how that works here, right? From milliliter to liter, that's smaller to bigger. Smaller to bigger should give you a negative exponent. So that's why 1 milliliter is 10 to the minus 3 liter. Okay, see how it works here too. Smaller to bigger, right? A microliter is smaller than a liter, right? Now, you may be asking me, wait a minute, how do I know that? Remember that table? Let's go back to the table, right? Go back to the table, right? It's going from biggest to smallest. So that's why you got to learn that first, right? Memorize in order: giga, mega, kilo, deci, centi, milli, micro, nano, and pico. That's the order. Giga being the biggest, pico being the smallest, right? So memorize it in that order so you know what's bigger than what, right? So again, back to here, right? I know that micro is down there, smaller than liter. So I'm going from smaller to bigger. So that's gonna be a negative exponent, -6, right? But here I'm going from bigger to smaller, right? Now I'm asking a different question. I'm like, 1 liter is how many milliliters? So I'm going from bigger to smaller. That should be a positive exponent. So I just flip the sign from -3 to +3. Same thing for micro, right? Liter is bigger than micro, so I'm gonna switch from -6 to +6. Okay. Um, and that's what you do, right? So you guys see what the exercise that I'm doing. You should also do this exercise. Do it both way for all of them. I've only shown you for 3 right now. Okay, you guys go and do the other 6, and you do it back and forth until you are well versed in that. Okay, I'm gonna show you one more trick. Okay, and then you guys go practice. Okay, because that's really all I can do, right? I can do all the examples for you. If you don't do it and figure it out on your own and doing some practice, you're not going to get it, right? But I will show you one more trick to help you learn this stuff. What you need to practice, right? Is go from top to bottom, okay? Top to bottom, giga, biggest, right? Then mega, then kilo, then that's the base, right? That's where um, the big numbers are. Then we go to the smaller numbers: deci, centi, milli, micro, nano, pico. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And remember for giga, it was 9, right? What's the exponent? Mega is 6, kilo is 3, deci is -1, centi is -2, milli is -3, micro is -6, nano is -9, and pico is -12 for the exponent. Okay. Well, I'm going to not even care about the negative, okay? I'm just gonna group things into the exponent. So I know that giga and nano is 9, okay? And then I know that mega and micro is 6, okay? I'm letting go of the negative and the positive, right? So I'm showing you a trick here. So don't worry about that. And then I know that kilo and milli is 3. 963. Pico is 12, right? So it's always going down by 3. It's easy to remember. And then, for deci, it's 1. For centi, it's 2. So, for these ones, let's do it like this. Yeah, centi is 2, deci is 1. So for these, just they're by themselves, right? So now when you do the conversion, you only have to remember the exponent and then the sign you can get from whether you're going smaller to bigger or bigger to smaller. Okay, so let's try it. So let's say I'm saying 1 microgram is how many grams? Okay, now that's the question. Okay, well, let's see. Micro is 6. So I know it's going to be 10 to the something 6. How do I get whether it's a negative or positive? Is it going from smaller to bigger or bigger to smaller? Well, micro, right, is here. Gram is here, right? Gram is the base unit. I call it base unit, right? There's no prefix in front. So this is the base, right? So micro is below gram, right? So micro is smaller. I'm going from smaller to bigger. It's got to be a -6. Boom. You see that? Let's try nano, okay? But this time I'm going to say 1 meter is equal to how many nanometers? Okay, 1 meter is equal to how many nanometers? Well, I know nano is associated with the number 9. Okay, so now I just have to figure out whether it's a positive or negative 9. Meter or nanometer is bigger. Well, meter is just a base unit. Nano is down here. So meter is bigger. I'm going from bigger to smaller, bigger to smaller. So that's going to be a positive 9. Okay, you guys see that? Okay. One more, right? Let's do centi. 1 centiliter is how many liters? Right, now we're doing volume. Oh, centi is 2. Right, we know what the exponent is 2. But is it a positive or a negative 2? Well, I'm going from smaller to bigger. Right? Smaller, centa is smaller than the base, right? Centa is down here in the basement. So 10 to the -2. I'm going from smaller to bigger. Okay. So honestly, sirs, I can do 25 more of these problems, 100 more of these problems. It's not going to help you, right? You need to internalize this and conceptualize this yourself when you're doing more practice. So that's why I would go through and just randomly ask yourself questions, right? And write these true statements. Okay? And, let me know if you guys have questions.